Hey everyone, and welcome to The Explainer. Today we're going to talk about something that is, and I mean this literally, holding our world together. It's in our buildings, our cars, our bridges, but you probably never even notice it. We are talking about the incredible power of welding. So let's jump right in. So, have you ever really stopped to think about it? I mean, how are gigantic chunks of metal joined together to make something like a massive ship or an offshore oil rig? It's not tape, it's not glue, and it's definitely not just a bunch of nuts and bolts. The answer is something way more fundamental and a whole lot stronger. And here it is, welding. The key word here is fusion. We're talking about a process that uses intense, focused heat to actually melt and merge metals together, so they become one single, solid piece. And here's the most important part. A good weld isn't just a connection, it's a permanent bond that's often even stronger than the original metal it's joining. So, here's how we're going to break it all down. First, we'll look at just how much of our world is fused together by welding. Then, we'll get into the basic anatomy of a weld. After that, we'll explore two of the biggest methods, using a controlled flame with gas welding, and then harnessing electricity with arc welding. And finally, we'll wrap up by looking at the incredible skill and safety that goes into the welder's craft. All right, so let's start with the really big picture. Because welding isn't just some niche thing for a factory. It is a foundational technology for almost everything we build. I mean, just look at this list. We're talking about the ships that cross oceans, the pipelines that stretch for thousands of miles, the bridges we drive over every single day without a second thought. Every single one of these amazing feats of engineering depends on countless, strong, reliable welds holding that invisible metal skeleton together. Okay. So before we get into the how, we've got to learn a little bit of the language. Let's dig into the basic building blocks and setups that every single welder has to know like the back of their hand. So to start, there are two really common ways you join metal. On the left, you've got a butt weld. That's pretty straightforward. It's just two pieces joined edge to edge on the same level. Then on the right, you have a fillet weld. You'd use that to join pieces at an angle, like for a T-joint or a corner. Sounds simple, but these two are the absolute bread and butter of welding. And you can't just take two pieces of metal and melt them together. For a really strong weld, you have to do some prep work. You can see here how the edges are often ground down into these V, U, or J shapes. This creates a little groove, a channel for the molten metal to flow into, making sure that fusion gets deep into the material. That's what gives it real strength. Now, a welder's job also gets a lot harder depending on which way they're facing. Welding on a flat table, that's the easiest. But now imagine you're welding vertically, trying to go up the side of a building, fighting gravity the whole time. And then there's the overhead position. You're welding above your head with molten metal dripping down. That right there takes an insane amount of skill and control. Okay, let's get into our first major welding process. This is kind of the old school method, and it's all about the precise, controlled use of a very, very hot flame. So the key thing to understand here is the heat source. With gas welding, you're mixing a fuel gas, like acetylene, with pure oxygen and igniting it. This creates a flame that can hit over 3,000 degrees Celsius, hot enough to melt steel like butter. The welder just carefully guides that flame along the joint, creating this little pool of molten metal that fuses everything together as it cools. And this is where the real skill comes in. It's not just a blowtorch. A welder has total control over the flame's chemistry. By tweaking the gas mix, they can create a perfectly balanced neutral flame for most jobs, a carburizing flame that has a bit of extra fuel, or an oxidizing flame with extra oxygen. It's kind of like being a chef, You have to get the recipe just right for whatever you're cooking. All right, so we've played with fire. Now we're going to talk about harnessing lightning. For real. This next family of welding processes is all about using the incredible power of electricity to generate insane amounts of heat. So here's the basic idea of arc welding. You run an electric current through a metal rod called an electrode. When you get that electrode close to the metal you're working on, the electricity literally jumps across the gap. That creates a continuous, incredibly hot and bright electric arc. That arc is your new heat source, and it instantly melts the metal right at that point of contact. Now, a really important difference in arc welding comes down to the electrode itself. As you can see, some electrodes are consumable. They're actually designed to melt right along with the workpiece, and they become the filler material that fills in the joint. But others are non-consumable. They're made of something like tungsten that has a crazy high melting point. Their only job is to create and hold the arc while the filler metal is added in separately. So check this out. Here's a perfect example.
A super common process is called shielded metal arc welding. You'll probably hear welders call it stick welding. The consumable electrode, or stick, has this special chemical coating on it. As the arc heats everything up, that coating vaporizes and creates this little cloud of protective gas all around the molten weld. That gas shield is crucial. It keeps oxygen from the air from getting in and messing up the weld, which would make it weak.
Okay, so we've seen the what and the how, but now let's get real about what it's actually like to weld. The pros and cons, the dangers, and the amazing level of skill it really takes.
You know, no process is ever perfect, right? On the one hand, welding is amazing. It makes super strong, permanent joints, and it can be really fast and cost-effective. But on the other hand, all that intense heating and cooling can actually create stress inside the metal. It also gives off harmful radiation, and to get a good, clean weld every time, well, that takes a very skilled human being.
And we really can't overstate the dangers here. That electric arc we talked about, it is blindingly bright. It pumps out so much ultraviolet radiation that it can seriously burn your eyes, kind of like a really, really bad sunburn on your retinas. That's why a welding helmet or a hand shield isn't just a good idea, it is absolutely 100% essential.
And the protection goes way beyond just the eyes. You're dealing with extreme heat, sparks, and literal splatter of molten metal. So a welder's gear, their personal protective equipment, includes things like heavy leather gloves and a full apron to keep them from getting seriously burned. This is a craft that demands total respect for the power you're working with.
And that really brings us right back to the beginning. Welding is this incredible blend of art and science. It's this craft of taking separate pieces and, under really extreme conditions, making them one. It's all around us, silently and securely, holding our world together. So, the next time you cross a steel bridge or see a skyscraper reaching for the clouds, just take a second and look for the seams. And ask yourself, what would our world even look like if we didn't have a way to fuse metal together? It's a world that's pretty hard to even imagine. Thanks so much for watching.